Welcome to 3.4, Using Quadratic Equations, Part 1. What we'll learn in 3.4 is to solve quadratic equations using the quadratic formula, analyze the discriminant to determine the number of type of solutions, and solve real-life problems. So previously, we solved quadratic equations by completing the square, or factoring, or just simply using the square root if we're missing the middle term, the bx term. We do have a formula that will solve any quadratic equation. Okay, so that's kind of the cool thing. It's kind of wrapping it all up. This works all the time. So your quadratic equation needs to be in the form ax squared plus bx plus c is equal to 0. This is the key thing. It must be equal to 0 or this will not work. If this is true, and we can rearrange it that way, we can plug it into a simple formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is a formula you probably want to memorize, mainly for the SAT, but you will be able to use the formula on the test, okay, and on your final. I'm okay with that. Just keep it close. All right, so let's take a look, see how this thing works. Solving an equation with two real solutions. So let's simplify, let's solve this for 0. So we need to get x squared plus 3x equals 5. We have to make sure it's equal to 0. So we're going to subtract 5 from both sides. That leaves us with x squared plus 3x minus 5 is equal to 0. Now we can use our formula. We need to identify what a is. A is the number that is the coefficient of the x squared term. So a and the coefficient of x squared is 1. B is the coefficient of the x term, which is 3. And c is your constant number there. So that's negative 5. We're going to plug into the correct spots using our formula. This formula right up here. Okay, we're going to use that. All right, so we're going to plug it in. So x equals negative b, the opposite of b, which will be negative 3, plus and minus, we're doing both, times the square root of b squared. B is 3, so 3 squared, minus 4 times a is 1, times c, which is negative 5. All over 2 times the a value is 1. So we start simplifying. Underneath the radical, the square root symbol is 3 squared is 9. Negative 4 times 1 times negative 5 is a positive 20. So I'm going to add 20. All divided by 2 times 1, which is 2. So we're still simplifying. So negative 3 plus or minus the square root of 20 plus 9 is 29, all over 2. 29 is a prime number. You cannot simplify that, so that is your answer, okay? If you want decimal approximations, you can break this up into 2 parts because this represents 2 answers. Negative 3 plus the square root of 29 over 2, and negative 3 minus the square root of 29 over 2. And you can simply put that in your calculator and simplify to get decimal approximations if you need that. If you don't, you can leave it in the previous form right here. This is perfectly acceptable. But you know some of the programs, they want you to break it into 2 parts. So that's just, remember, it's 2 answers. Let's go on to example 2. Solve an equation with one real solution. So let's solve this. Now again, you need to isolate or get everything over to one side so it's equal to 0. We'll subtract 12x and add 4. We're going to simplify. You get 25x squared. Negative 8x minus 12x is negative 20x. And then you only have plus 4 on that side. And that's equal to 0. That is key. You have to get it equal to 0. This will not work. Let's identify a, b, and c. A value is the number in front of the x squared term, which is 25. B value is in front of the x term, which is negative 20. And C is your constant, which is 4. So let's plug it into our quadratic formula. And if you don't know it and you want to memorize it, which you need to do for the SAT and stuff, I would just write it every time. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Writing it over and over again helps you memorize. So and that's what x equals. So if you're one of those people that need to write things out repeatedly to memorize it, I would suggest every time you use it, just write it. Okay, here we go. So x equals opposite of b, which is positive 20, plus or minus the square root of b squared, which is negative 20 squared, minus 4 times a, which is 25, times c, which is 4. All over 2 times a, which is 25. All right, so let's start simplifying. 20 plus or minus the square root of negative 20 squared is 400, minus 4 times 25 is 100, 100 times 4 is 400, divided by 2 times 25, that is 100. No, it's not, it's 50. Sorry about that. So we get x equals 20 plus and minus, now square root of 400 minus 400 is 0. What is the square root of 0? It's just 0. So this ends up being 20 over 50. Reduce the fraction, it's 2/5. So this one only had one answer. So when you have 0 end up under your radical symbol, your square root symbol, you will actually only get one answer. And we know that if we graph this, the only way we get one answer is if the vertex is on the x-axis. We're looking for that point right there, okay? So keep that in mind. Sometimes it has one answer. Sometimes it has none. Sometimes they're imaginary. Let's look at one of those. I think the next one's like that. Let's look at example 3. Solve negative x squared plus 4x equals 13 using the quadratic formula. So again, move everything to one side. So I'm going to subtract 13 to the left side. So negative x squared plus 4x minus 13 is equal to 0. It's equal to 0, we're good to go. So let's identify a, b, and c. A is negative 1, b is 4, c is negative 13. Now, I do this for note purposes to write out what a, b, and c is, but if you don't need to, when you're using the quadratic equation, you don't have to. I don't when I'm solving this, so it's kind of up to you guys, okay? Formula. When I tell you about the formula, write it until you memorize it. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug in. The opposite of b is negative 4 plus or minus the square root of b squared, that's 4 squared, minus 4 times a is negative 1, times c, which is negative 13, all over 2 times a, which is negative 1. Simplify. We got 4 squared is 16. Negative 4 times negative 1 is positive 4. Positive 4 times 13. Is that right? Yep, 52. So it's negative 52. All over 2 times negative 1 is a negative 2. So then we combine 16 minus 52, and we get negative 36. Now we know we're not technically allowed to take the square root of negative numbers. So therefore there is no solution, but we can find the imaginary solutions, okay? So we need to keep on going. So let's take a look here. We know that this looks like the square root of negative 1 times 36, okay? Well, the square root of -1 is I. And the square root of 36 is 6, so it's 6I. So we could simplify that. Divided by -2. Now, we could stop here if we couldn't reduce, but notice how all three of these are divisible by 2. See, -2. -4 divided by -2 and 6 divided by -2. So let's do that. So -4 divided by -2 is a +2. We're talking about both signs here for like plus and minus 6I. So I'm going to divide it by -2, becomes 3I. But I'm already considering both positive and negative, so I don't have to worry about the signs there, okay? Because positive 6I divided by -2 is a negative 6I, and negative 6I divided by -2 is a positive 3I. So you get the positive and negative version, and we're already still taking account for that, so you don't have to worry about that. And that is your answer. There's our two imaginary answers, okay? And just remember that if you have this, you're just dividing each one of them by that number, and you can reduce them like fractions, okay? That is all we're going to do for this lesson. We're going to finish up the rest of them with the next lesson, okay? See ya. Bye.